Alright class, the last thing we're going to do in this little mini unit is graphing tangent and cotangent. So, first thing I want you guys to see is that on the unit circle, tangent, remember, is y over x. Except for I wrote the point wrong here. This should be a 1, 0. So tangent at 0 degrees is equal to 0 over 1, which is equal to 0. And then at 90 degrees, when the point is 0, 1, the tangent at pi over 2 is equal to 1 over 0, which is undefined. And then what happens is this value is the same as this value, but it's negative. This value is 1, negative. This value is negative 0.577, and then this goes back to 0. And then remember, tangent is positive again in quadrant 3. So these are all the tangent values in decimal form. And again, down here it's undefined. And then tangent becomes negative again. So let's think about what that looks like. I have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Where is it undefined? Well, it's undefined when the x is 0 or the cosine is 0, because you can't divide by a cosine. So right away there's an undefined value here and here. Where is it 0? It's 0 at 0, pi, and 2 pi. We're also going to call those the turning points because the tangent graph looks like a kind of like a cubic, a little bit, not really, but. And then notice what happens. So at 0, then at pi over 6 we're at 0.5, so we're about here. Then at pi over 4 we're at 1, and then we're up here. So what it looks like is this, and it approaches this forever. It gets bigger and bigger and bigger. Then on the other side of this, it's at negative 1.732, right about here. So if you see the pattern, tangent kind of looks like this. Okay? So it kind of, so that is, and remember how tangent has 2 cycles in 360 degrees, or 1 cycle in 180. This is 2 cycles. So that is the graph of tangent. So the asymptotes occur at pi over 2, always, and, well, unless there's a shift, 3 pi over 2. And we're going to graph 2 cycles so it matches what we were doing with the other curves. So let's see what happens. We're going to shift them. So right away, I'm going to write down for a normal tangent graph, my turning points are at 0. My asymptotes are at... Actually, before we do that, let's look at what this means. The normal graph is going to go up 2, and this means it's going to the right by pi over 4. So that means that all my points are moving to the right, which means I'm going to add a pi over 4 to all of my original points. So when my asymptote's at pi over 2, I need to add pi over 4 to it. My other asymptote is 3 pi over 2, and I have to add a pi over 4 to it. I have another, those turning points, I have one of them at 0, I have to add a pi over 4. The other one's at pi, I have to add a pi over 4. And the other one's at 2 pi, and I have to add a pi over 4. So all I'm doing is taking the original graph and shifting all those special points. So what do we get when we do that? We get that this is 3 pi over 4 and 7 pi over 4 for our asymptotes. And then we get, for down here, I'll do it down here, we get pi over 4, 5 pi over 4, and 9 pi over 4. Which means the graph is going to start at pi over 4 and end at 9 pi over 4. So here's pi over 4. And what's nice about this is you don't have to really figure out an interval because all the points are given. So the other place where it's a turning point is 5 pi over 4, and then the asymptotes are at 3 pi over 4 and 7 pi over 4. Alright, so that's the graph. And then the other thing we need to note is that the graph is shifted up 2. So my turning points are going to be here, here, and here instead of at the 0. My asymptotes are still here and here, and now we just graph it. So I'm going to start at pi over 4 and go up. Then it comes from the bottom, it turns through there and it goes up. And it comes from the bottom and it hits the turning point. So that is one cycle of tangent, and again, all you have to do is find those 5 values by shifting it, and then shift it up or down, and you're good. Let's do one more. Again, our asymptotes are normally, well, let's figure out what's going to happen. This is going to go down 1, and this is going to go left pi over 3. So we're going to subtract pi over 3 from all of these points. So that means that I have pi over 2 minus pi over 3, and I have 3 pi over 2 minus pi over 3. For the turning points, I have 0 minus pi over 3, pi minus pi over 3, and 2 pi minus pi over 3. Okay, so I do that. These two become pi over 6 and 7 pi over 6 for the asymptotes. Down here we get a negative pi over 3, we get a 2 pi over 3, and what is that, 5 pi over 3? So again, I just graph from negative pi over 3 to 5 pi over 3. It's always the two turning points or the end points. The middle would be 2 pi over 3. Now my asymptotes are at pi over 6 and 7 pi over 6. And then the 0 is somewhere in here, and we're down at negative 1. So I'll just draw an axis here and say that we're at negative 1. So I'm going to put my points on here and my asymptotes. My asymptotes are here. And my turning points are here, here, and here. So then you just do what we've been doing. And then that's it. So that's how you graph tangent. Pretty easy. But that's what tangent looks like. It has asymptotes every 180 degrees because it's undefined. Now we're going to do cotangent real quick. Remember, just at this point, tangent is equal to 0 over 1. So cotangent is equal to 1 over 0, which is undefined. And then what happens is, at these points, you get 1 over 0.577. You get 1 over 1, so that's the same. And then you get 1 over 1.732. And then when you flip 1 over 0, this flips back over and becomes 0. So what's happening is, I'll show you kind of what this looks like. Pi over 2. Okay, so our undefined is now at 0, at pi, and at 2 pi. So what happens is we have asymptotes here, here, and here, so the asymptotes change. The zeros are now here and here, and look at what happens. 1 over a half is about 2. So over here, it's up here, and then it comes down towards the 0, and then it goes negative and gets bigger. So cotangent kind of looks the other way. It starts high and goes low because it flipped over. And then this one does the same thing, and then it's over. So this one you can see, I should write cotangent here. This one you can see both cycles together, but notice how it kind of starts up high at the asymptote and goes down. But the principle is the same. We have turning points and we have asymptotes. So the tangent function and the cotangent function are reciprocals. We know that cotangent of theta equals 1 over tangent, or that cotangent is equal to cosine theta over sine theta. On the tangent graph, we had certain angle measures that gave us asymptotes and certain angle measures that gave us x-intercepts. Because we were taking the reciprocal of the tangent graph, values that originally gave us the x-intercepts will now give us an asymptote, and values that originally gave us an asymptote now give us an x-intercept, or turning point. The asymptotes will occur at, so in this case now the asymptotes are at 0, pi, and 2 pi. And then our turning points will be at pi over 2 and 3 pi over 2. So let's do this again, just like we did before. First, figure out the shifts, down 2, which just affects where you put the turning points. And then this means pi over 6 to the left. So we're going to subtract. So this time, the asymptotes are what the zeros are before. So it's 0, and then we're going to remove it, or move it pi over 6, pi minus pi over 6, and 2 pi minus pi over 6. For the turning points, it's pi over 2 minus pi over 6, and 3 pi over 2 minus pi over 6. We calculate those values, you get negative pi over 6, you get 5 pi over 6, and 11 pi over 6. And these will be the values you use to make your number line. What is this? 6, what is it? Pi over 3, and 4 pi over 3. So I do my graph. Negative pi over 6 is here, and 11 pi over 6 is here. The middle is 5 pi over 6. This is pi over 3, and this is 4 pi over 3. So now my asymptotes, oh, and I need to draw my 0 somewhere. So here's my axes. I'm sorry, my negative 2, 1, 2. So my turning points are now at pi over 3 and 4 pi over 3. My asymptotes are here, here, and here. And then we just draw a normal cosine or cotangent graph. It starts up high, it turns there, goes down forever. Starts up high, turns there, goes down forever. And that's it. So let's do one more, and then we'll call it a day. This is up 1, and this is to the right for pi over 4. So the asymptotes again are at 0, pi, and 2 pi. But again, we're shifting it pi over 4 to the right, so we have to add that to every point we have. Pi over 2 plus pi over 4 for the turning point, and 3 pi over 2 plus pi over 4. So we get pi over 4, 5 pi over 4, 9 pi over 4. Down here we get 3 pi over 4 and 7 pi over 4. So I start at pi over 4 and I end at 9 pi over 4, and I have a 7 pi over 4. That doesn't make sense. I should change that to a 5, because that is the middle point. Here's my 3 pi over 4 and 7 pi over 4. Okay, and then there's the axes over here. We're going up 1, so here's 1. So the asymptotes are at pi over 4, 5 pi over 4, and 9 pi over 4. My turning points are here, and since it's a cotangent graph, it starts at the top here and turns through that point. And there we go. Another 2 cycles of cotangent. Alright, so that is it for graphing cotangent and tangent.